Hello, friends and followers. Welcome back to another edition of Things You Shouldn't Say on TV. No, wait, that's wrong. A New Way to Museum. I am your host for the day, Curtis Schmidt, the Zoological Collections Manager. As you notice, we're doing things a little differently today. We're actually taking the video to the field, and I am surrounded by third graders at Wilson Elementary School right now. Say hi, third graders. Hi! So what we're talking about today is science and the scientific method. Something that's very, very important right now. Whether you're a kindergartner or a grown adult, this is something that you need to know throughout your entire life. So I'm going to start out with just a couple vocabulary words that you may or may not be familiar with and what the meanings of those words are. You've probably heard them before. So first, what is science? Science is actually knowledge of the physical world gained through observation and experimentation. So basically, it's a way that we gain knowledge about anything going on in the world right now. Okay, that's science. So what is research? That's another one that's really, really tied closely to science. And there's a couple different ways you can answer that. The ones that I like right now, and it's both a noun and a verb. Okay, so as a noun, it's investigation into a subject in order to discover or revise, and that's important, facts or theories. So I'm going to say that again. Investigation into a subject in order to discover or revise facts or theories. That revise is very important. I actually had this discussion with someone yesterday who was saying that they don't believe in science because science has been wrong in the past. Science is always wrong. Scientists are always wrong. That is central to science. It's always building on that information. Whether you're right or you're wrong, it's constantly building on that information to come up with your best answer to the problem. Okay, so as a verb, it's to investigate carefully. So to do research on something is to investigate it very carefully. Right? That makes sense. So now I'm going to go into the scientific method. Now this is something that you guys are going to see a lot in your lifetime, in your schooling. It's never going to be the same. So lots of textbooks do things differently. They add a couple different steps, or they take off some of these steps that I'm going to go through. But these are the ones that I think is most important for you guys to learn at this age, okay? So the very first one is probably the most important. Observation. So you're out and about, you see something that catches your interest. You make an observation. You say, well, that's interesting, right? How did that happen? Why did that happen? An observation, well, this is what's interesting. It's not always something that's in front of you that you can see. An observation can also be observing where there's gaps in information, where there's things that we don't know. That can also be an observation. Does that make sense? So it's not just something you see, but it's also something you don't see because it's not there. We don't have that information. Okay? So second, based on that observation, we form a question. Why is it that way? What made it that way? What caused what we just saw? Why is that information that's missing lacking? Why do we not have that information? So there's our question. 3, and I'm going to use this a couple times, research. And this is one you're not always going to see in typical textbooks. Because after you make an observation, then you question something, the first thing you have to do is go through the literature, see what's been written, and see if there's actually answers to your question out there already. So you need to see if someone's already done that research and if there's already answers out there. That's very important. That takes a lot of time, too, in the scientific process. We're lucky today in that we don't have to go to a library and look through all these journals and all these books and things. We can just get on the internet and do quick searches, right? We can see what's out there. So the next one is we form a hypothesis. That's the big word. And I'm not going to go too in depth as to what that means for you guys. This is something you'll learn later. But a hypothesis is basically what you think the answer to that question is. Okay, and I'll give you some examples here in a little bit that might help set the tone here. And the hypothesis, it's not just one statement. It's two. They come in pairs. So one of them says X because of Y. The other one says X not because of Y. Does that make sense? So one of them shows there's a relationship. The other one says there is no relationship. So what we're going to do is we're going to collect data and try to find results to see which of those statements is going to be false. Okay? I'll give you a good example here in a little bit as well. Now it's time for the fun stuff. Experiment. That's my favorite part. That's fun, especially when you're studying wildlife. Because you get to go out and you get to use lots of cool tools to try and answer these questions and collect data. So what you're doing is you're collecting information that's going to help you answer your question. Okay? Then we're going to analyze the data. So all the data that we just collected doing our experiments, we're going to analyze. And I'm not going to go too much into that either. Okay? But we're going to analyze those data, try and figure out which hypothesis is going to be the best to support and get rid of. Okay? The last one. And even though it's at the bottom, it's probably the most important. Communicate the results. So remember back up here when we were doing research? We were looking to see if anyone's done that before. So after we do it, we want to communicate the results. Now the way that we do that, the best way to do that is to publish. So it's always good to be a very good writer. So, at your age right now, you're trying to figure out, well, what do I like the most? Do I like science? Do I like writing? Do I like PE? What do I like? A lot of these things are intertwined and very, very related. Most scientists are very good writers as well. In fact, to get my master's degree, I had to take 2 separate classes just in scientific writing. And the reason why is so that we can do this and we can do it properly. So here's a few of my more recent publications. So this is me communicating results. Okay? We publish those things typically in scientific journals. So I have 3 examples of scientific journals right here. So this is a local one that is just Kansas. Okay, you can see that right there. Transactions of the Kansas Academy of Science. Then you go out a little bit to a regional journal, the Southwestern Naturalist. So that gets a little bigger audience, but it's not restricted just to Kansas. And then there's a host of journals that are international, so worldwide people can publish in these. So if you want to reach the entire world, there's lots of journals out there for you to publish in. So again, I can't say that enough. Very, very important to effectively communicate the results. So when somebody comes upon the same observation that you did and sees the same thing, when they get to this research step, they can see that, oh, it's been done already. And then they're faced with the choice, well, should I do it again to see if I get the same results? Because people do that all the time. That's the beauty of science, is it's repeatable. You've got to be able to repeat it and get the same results over and over again. Think of a chemistry experiment or something like that. You want to be able to get the same result every single time you do those experiments. Okay? So, not all research has to answer questions. Basically, what we call that is descriptive research. Because if you think about certain animals that you know, like bats. There's lots of information out there, but we don't know everything about bats. We don't know where they live, what they eat, what they do at night, what they do during the day. We don't know all that stuff. So like this journal right here publishes nothing but descriptive research. So it's not trying to answer questions, but it's filling in holes in our information, things that we don't know. So new places where organisms are found. New things found in their diet that we didn't know that they ate. Things like that. So usually shorter notes, which is what these two that I showed you before, these are descriptive. That's the type of research that I mostly do, is descriptive. So here's the title of this one. Presence of the evening bat in westernmost Kansas. So until I caught this bat right by Colorado, it had never been found that far west in Kansas, not even close. So that was the first time that it was published and shown that they were that far west, which is interesting because that species of bat, the evening bat, has been moving west very, very rapidly in Kansas and Oklahoma, Nebraska, all those states, moving west very, very rapidly. So it's important that we track that and see how fast they move and then try and figure out why are they moving. So there's your question. Why are they moving west? And then we can try to answer those questions. So I'm going to give you a simple example that you guys should understand of the scientific method here, okay? All right, so say for instance we make an observation. So the school nurse notices that there's a big increase in the number of students coming in with broken arms. Okay? Same time, the teachers that are on recess duty notice there's more and more kids using the slipper slide. So there's an interesting observation. More people using the slipper slide and more broken arms. So here's our question. Is the slipper slide causing broken arms? Seems kind of silly, huh? Well, there's a way we can test that. So first thing we're going to do is do research to do what? To try and find out if anybody's done that before. If we know the answer to that question, then we're going to generate a hypothesis. So my hypothesis would be the slipper slide is not causing more broken arms. Because to me, that just doesn't make a whole lot of sense. Okay? So we've got a hypothesis set. That's my hypothesis. The other one is going to be, it does cause more broken arms, the slipper slide. So we're going to collect data to try and figure out one of those hypothesis set, which one of the hypothesis set is true and which one is false. Okay? Now we're going to experiment. So we have to design an experiment. So in my mind, I'm thinking we're going to take a whole bunch of kids. We're going to separate them into two groups. Okay? We're going to send one group down the slipper slide, one at a time. We're going to set the other group against the wall for recess. So they're not going to get to do anything. Why would that be important?
Because the people that have the wall,
That's right, they wouldn't get a broken arm. But here's the deal. There's lots of other equipment out there that could be breaking people's arms, right? So we're not going to know if it's a slipper slide if other people are out there breaking their arms on other stuff. So we have to have half the group doing nothing, half the group going down the slipper slide. So after we compile all those, we analyze the data, we find out no broken arms, whole bunch of people going down the slipper slide. What's our result? What's our conclusion? It's not breaking their arms. So we're going to keep my original hypothesis. Does that make sense? So slip or slides are not causing an increase. But here's the cool thing about science. We're not going to stop there. We're going to move on to the next piece of equipment. So we can try and figure out where they're breaking their arms more than they were in the past. Right? Probably the monkey bars or something like that, right? Yeah. So anyways, you guys all follow that? Pretty simple scientific method there. All right, so you guys have probably wondered why I've got this cool stuff up here. So this is going to be a little more complicated. This is some of the research that I've done. I'm going to start off with just a little bit of background information. Okay, so about 15 years ago, a disease started hitting bat populations on the East Coast, so over by New York. Well, that disease quickly spread from east to west. And the bad thing is, as it was spreading and as it was moving, it was completely wiping out bat populations. There were certain populations of certain species in the east that were decimated. 99% of the bats were killed by this fungus, by this disease. So here's the crazy thing, okay? Give me a second to do a terrible drawing. Let me see if you guys can figure out what this is. What is that?
Kansas.
That's the state of Kansas. What's this?
Haze.
That's haze. All right. So the species of bat ended up being put on the federal endangered species list. Okay? Well, this happens to be a species that we have in the state of Kansas. And it occurs, luckily for us, right here. From Hayes North, in that little tiny pocket right there. Okay? So, my observation. Okay, we now have a protected species. Very protected species, getting wiped out throughout most of its range. Okay? We didn't know anything about this bat in Kansas. Like nothing. This is all we knew. We knew where it occurred. That was it. So now we're going to have a protected species that we have to protect. We have to manage for it. We have to tell landowners what they can and can't do based on whether or not they've got this bat present, but we know nothing about it. So again, that goes back to what I said earlier. My observation is there's a huge lack of information here. So I jumped all over that. I got over $300,000 to study this thing. Yes, for 3 years, we studied this thing very much to learn all sorts of things. So we have all sorts of questions. Where does it live? When does it live there? When does it have its young? Where does it raise its young? Where does it roost during the day? Where does it roost during the night? All of these questions. What is it feeding on? What parasites are feeding on it? Things like that. So we set out to answer these questions. This is where it gets fun. So I'm going to show you how we went about answering some of these things, because bats are really tough to study. Why? Because they can fly. They're really hard to catch. They're really hard to find. And so therefore, studying their habitats and what they're doing by day and by night is difficult, especially by night, because they're flying around feeding at night. But we can know where they're going during the day. So one of the questions, this is where we start with. How many are there? How big is our population? So within this area, how many of those individuals are in these populations? Okay? So we're thinking, how do we do that? How do we count bats in a population? How do you know you're not capturing the exact same bats over and over again? I'm going to answer that question. You guys see this little thing right here?
Yeah.
It's a little metal band on its arm. Little tiny band.
No.
It's real hard to see. But you can slide it up and down. It doesn't hurt the bat. It's not going to get in its way. The bat cannot remove it. It's going to be there forever. So the cool thing about it is this is band number FHSU 0612. And you saw how tiny that is. Try reading that on there. Okay? It's printed on there very, very tiny. Yes, I have to use glasses too now. So that's a way that we can actually see if we're catching the same bats or not. Simply throw a band on there. But that also gives us cool information, like are they coming back to the same roosts? Are we catching them in the same areas? Both within that year and in sequential years. So we banded bats that we caught 3 years later in the exact same spot. That's cool stuff. That means they're coming back to the same spot, or they're never leaving, right? Cool stuff. So if we want to get into more detail and look at their habitats and when they're leaving and things like that, it gets a lot more complicated and a lot more difficult. So again, we're talking about bats that are teeny tiny because the bat that we're studying is called the northern long-eared bat. Happens to be the smallest bat that we have in the state of Kansas. Little, tiny, little bat. Which makes it a challenge. So y'all see this right here?
Yes.
This might help. Can you see that? I got a big head. But you see that. So I'm holding to an antenna. The rest of it is a radio transmitter. This is the smallest radio transmitter that you can buy. This right here costs $200. $200 for this one little thing. And if you're lucky, you can get readings off of it for a week. And then it's gone. So sad that it's that expensive, but what we do is we shave a little spot between the shoulder blades of the bat and we glue it on there. So now the bat's flying around, the transmitter is putting out radio frequencies, and we tune this little thing in. This is the antenna, so that's how it's getting that information out there, those radio waves. And then this guy right here is a receiver, and this is an antenna for the receiver that plugs into it. When we go out, we tune that in to the specific frequency of that transmitter, and then we go look for the bat. So basically we usually put headphones on so that we can hear it. And as we get closer to it, it beeps. So if it was over there, no beeps, no beeps. Getting louder, beeps. So we can pinpoint it's that direction. As we get closer to it, it'll beep louder and louder and louder until you're right on top of it. So that's how we find them. And then, after we find them, we can study the habitat around them. And as I mentioned, this is usually done during the day because the bats are roosting during the day. So they're flying around eating at night, really hard to track them when they're doing that. You need a team of about 5 or 6 people. We only had 3. So doing it during the day is the only way. And we're answering lots of questions by getting the data. Where are they roosting? What trees are they roosting in? What is the habitat surrounding what they're doing? Really interesting stuff. And then we can also get an idea of their movement. So when are they leaving the roost? When are they coming back to the roost? Things like that.
Thanks for joining us in A New Way to Museum with the Sternberg Museum of Natural History. If you enjoyed this video, like it and subscribe to our channel. Hit the bell for notifications when we release a new video. Support us on Patreon for early access and exclusive content. You can also follow us on all our social media. Links are found in the description. Thanks for watching, and follow your curiosity to new discoveries.